Hi, good morning, dear friends. So, in the previous class, we learned about Newton's first law of motion, also inertia. So, and also the Newton's first law, why it is called as law of inertia? Because according to inertia, it is a physical quantity that forces the object to remain in the state of rest or of uniform motion. And according to Newton's first law of motion, every object continues to be in the state of rest or of uniform motion unless an external force applied on it to change that state. That means whenever we apply force on an object, then only that object starts to change its original position. So your original position are considered as rest position or uniform motion position. And now in this class we are going to learn Newton's second law of motion and what are the application of it. So Newton's second law of motion. Newton's second law of motion. So this statement also you learned in 8th standard. So according to, just note down the definition of Newton's second law. Acceleration, according to Newton's second law of motion, acceleration given to a body is directly proportional to applied force and in the direction of the force, and it is inversely proportional to mass of the object. So I will repeat that statement. According to Newton's second law of motion, acceleration given to a body is directly proportional to applied force and in the direction of the force, and it is inversely proportional to mass of the object. See the acceleration given to a body is directly proportional to applied force. Body is directly proportional to applied force and in the direction of the force. So the acceleration is directly proportional to applied force and in the direction of the force and in the direction of the force and it is inversely proportional to mass of the object, and it is inversely proportional to mass of the object. Just note down the statement correctly. Acceleration given to a body is directly proportional to applied force and in the direction of the force, and it is inversely proportional to mass of the object. Inversely proportional to mass of the object. Okay, who knows the mathematical expression of Newton's second law of motion? If you know, then comment me that mathematical statement. So what is the expression of Newton's second law of motion? So here two parts are given. First one is the acceleration given to a body is directly proportional to applied force and in the direction of the force. That is the first statement. And second one is acceleration given to a body is inversely proportional to mass of the. One is acceleration is directly proportional to applied force and in the direction of the force, and second point is acceleration given to a body is inversely proportional to mass of the object. This is meaning of the statement. So now we have to frame the mathematical expression by using these two statements. Okay. So just I will write the given statement in two parts and I will form the mathematical expression for Newton's second law of motion. Okay, the total whole expression we have to divide that into two parts. First one is the acceleration given to a body is directly proportional to force and in the direction of the force. That is the first one. And second one, acceleration given to a body is inversely proportional to mass of the object. First one, acceleration is directly proportional to applied force and in the direction of the force direction of the force. Acceleration given to a body is directly proportional to applied force and in the direction of the force. So that it means A is directly proportional to F. So we will call this as equation number 1. Okay, equation number 1. Now second statement, acceleration given to a body is inversely proportional to mass of the object. Second one, acceleration is inversely proportional to mass of the object. Inversely proportional to mass of the object. So that's why the expression becomes A is inversely proportional to M. So we'll call this as equation number 2. Just look at the two expressions. So now based on these two expressions, we have to frame the expression for Newton's second law of motion. So see here, both equation 1 and 2 on the left hand side is having A, that means acceleration. That means according to axioms, if two things are equals to same thing, then that two things are equals to each other. Similarly, if two things are proportional to same thing, here, okay, force is directly proportional to A and 1 by M is directly proportional to A. Therefore, by combining equation 1 and 2, by combining equation 1 and 2, what it becomes? Acceleration is directly proportional to F divided by M. So F is in the numerator, M is in the denominator. Therefore, A is directly proportional to F divided by F. So this is the first part. Then next part of this derivation. Now we have to remove, this is proportionality symbol. Now to remove that proportionality symbol, we have to add one constant term here. To remove proportionality symbol, we have to add one constant term. So therefore I will add K into F divided by F. 1. So here K is constant. Here K is a constant term. We will consider as a constant term. So when K equals to 1, when the K value, because we already consider K is a constant. Now in this case I will consider K equals to 1. So then what it becomes? K equals to 1 into F divided by F. So this implies K equals to 1 into F, that is F only, divided by F. So therefore by cross multiplication method we will get, so when we cross multiply it becomes F equals to m into a. So F equals to m into a. This is the mathematical expression for Newton's second law of motion. Okay, F equals to m is the mathematical expression of Newton's second law of motion. According to Newton's second law of motion, acceleration given to a body is directly proportional to applied force and in the direction of the force, and it is inversely proportional to mass of the object. Just look at this expression. And how many of you understood this? Just comment your name and click on the like button. Fast. Very simple derivation. So mathematical expression of Newton's second law of motion is F equals to ma, where F is force and SI unit of force is Newton, and m is mass of the object, and SI unit of mass is kilogram, and a is acceleration, and SI unit of acceleration is meter per second square. And next, so here we have the expression, that is F equals to m into a. So that is force is equals to mass into acceleration, or force is product of mass and acceleration. And in the previous chapter, while solving the problems, we used one expression for acceleration. So one is in the equation for motion. First one is v is equals to u plus at, or we wrote that as a is equals to v minus u divided by t. So by rearranging v equals to u plus at, we wrote that a is equals to v minus u divided by t. So now we'll substitute this value of a in this expression. So we'll substitute the value of a in this expression. It becomes F equals to m into, in the place of a, what I have to substitute? I have to substitute v minus u divided by t. So it becomes v minus u divided by t. V minus u divided by t. Therefore, the expression for force, when mass and the initial and final velocity and time are given, then the mathematical expression for the force is F equals to m into v minus u divided by t. Now there comes another term, that is momentum. So momentum means it is a product of mass and velocity. I will explain about this later, but for the mathematical expression I will use the definition. So just remember the definition of momentum. Momentum means it is a product of mass and velocity. Okay, m into velocity. Either it is initial or final. So that's why we multiply these terms. F equals. So it is multiplication of monomial and binomial. So neglect the denominator. M into v minus m into u divided by t. Okay. So here mv means it is momentum. Mu means it is momentum. V means your final velocity. So that's why mv means final momentum, and u means initial velocity. That's why mu means initial momentum, and t is time, and f is force. When we cross multiply, it becomes f into t, that is equals to mv minus mu. Okay, mv minus f into t, that is equals to mv minus mu. So now just comment me, what is the SI unit of momentum? What is the SI unit of momentum? Comment me that answer. What is the SI unit of momentum? So someone asked, so when the mathematical expression of force is asked, which one we have to write? Okay. So mathematical expression for force. So in different concept we are using different expression for force. Okay. But while solving the problems, which is the required mathematical expression, that one we have to use. For example, if acceleration and mass is only acceleration and mass of the object is given, then in that problem we have used F equals to m into a. So this expression you have to use. If acceleration is not given, so mass, initial velocity, final velocity, time is given. In that case, you have used F equals to m into b minus u whole divided by t. This expression you have used. Okay. So based on the requirement, we have used the expression. Only if they ask what is the mathematical expression of Newton's second law of motion, in that case we have used F equals to ma. Okay, that is the mathematical expression of Newton's second law of motion. So now I asked what is the SI unit of momentum. So momentum means, so I will write the definition. Okay, momentum, it is the product of mass and velocity. Momentum. What is meant by momentum? Momentum means it is product of mass and velocity. Product of mass and velocity. Product of mass and velocity, that is called as momentum, and the symbol used to represent momentum is small letter p. Symbol is small letter p, that is used to represent the momentum. And expression, okay, this is symbol. Listen the words carefully. This is a symbol used to represent momentum. Now I'll tell you the expression. Expression for momentum, that is p is equals to m into v, or we can consider m into u. So both are the expression for momentum. Generally we will write p is equals to m into v. Then SI unit. SI unit is, so SI unit of mass is kg, SI unit of velocity is meter per second. Kg, meter per second is the SI unit of momentum. All small letter k, g, m bar s, or we can write kg m s raised to minus 1. Kg m s raised to minus 1. We can write both expression or both as the SI unit. Either we can write kg meter per second, or we can write kg m s raised to minus 1. Just note on that points. So now we learned about Newton's second law of motion and momentum. Now the next concept. That is Newton's third law, very simple and easiest law. Newton's third law of motion. Newton's third law of motion. Just comment me the statement of Newton's third law of motion. Okay. In that time I will repeat. I will tell you the. And once again tell you the definition of Newton's first law and second law. You have to comment me the definition or statement of Newton's third law of motion. Comment me the statement first. According to Newton's first law of motion, every object continues to be in the state of rest or of uniform motion unless an external force applied on it to change that state. I am repeating all these statements repeatedly because they are very important statements. Okay. And then according to Newton's second law of motion, acceleration given to a body is directly proportional to applied force and in the direction of the force, and it is inversely proportional to mass of the object. The next comes the momentum. Momentum means it is product of mass and velocity. And the SI unit of force is Newton, SI unit of acceleration is meter per second square, SI unit of velocity is meter per second, and SI unit of momentum is kg meter per second. Okay, how many of you commented the statement? Force is a push or a pull that acts upon an object in result of its interaction with other object. And someone commented as for every action there is equal and opposite reaction. Nagra and Chetan, two different statements. Any other statements? Apart from these two statements, any other statement if you have, then comment me that. What is the method? What is the statement of Newton's third law of motion? So the statement of Newton's third law of motion is for every action there is equal and opposite reaction. This is the perfect statement for Newton's third law of motion. For every action that is equal and opposite reaction. For every action there is equal and opposite reaction. So which are the examples for Newton's third law of motion? So comment any examples for Newton's third law of motion. Which examples are suitable, or which our daily activities are suitable for Newton's third law of motion? Which situations or which our daily activities are related or they are under the Newton's third law of motion? If you know such examples, then comment me that. First, action and reaction of equal reaction. Examples for Newton's third law of motion. According to Newton's third law of motion, it states that for every action there is equal and opposite reaction. We give the answer as football, and Shilpa gave the answer as gun. Any other answers? Which illustrates Newton's third law of motion. Comment your answers fast. So starting I got two examples. One is football and another one is gun. So that is incomplete example. So what is the complete example? Means if you consider football, kicking a football, when it kicks it moves. So that on the object, so football is one object and we are applying force and it is moving in the same direction. But here according to Newton's third law, for every action there is equal and opposite reaction. So instead of that, if you consider gun means if you fire, the bullet moves forward direction and the gun recoils. So recoil means gun comes in the backward direction. That is a simple example for Newton's third law. So if you consider a gun and a bullet, when we fire, then bullet moves in the forward direction and the gun moves in the backward direction, or recoil of the gun is occurs. Okay, so bullet moves in the forward direction and the same amount but in opposite direction the gun recoils. That is one example. And while swimming, we push the water backwards to move forward. When we swim, we push water backwards. Okay, we push water backwards to move forward. These are very two simple examples for Newton's third law of motion. Or simply touch me not plant. So when we touch the leaves of the touch me not plant, it suddenly reacts. Okay, it suddenly reacts. So these are the examples for Newton's third law of motion. The next one, if you consider momentum, so as I told you that momentum, it is a product of mass and velocity. It is a product of mass and velocity. So momentum means it is a product of mass and velocity. So that is P is equals to mv. So there comes another word, that is conservation. That means conservation of momentum. So what is meant by conservation of momentum and what is meant by momentum? So momentum, as I told you that momentum means it is product of mass and velocity. Either it is initial or it is final. But when we consider the word conservation, so as a prefix to the momentum, that is conservation of momentum. So that means the momentum before an event, that is same as momentum after the event. Momentum before an event, that is same as momentum after that. Just note on the definition of conservation of momentum. Conservation of momentum. Conservation of momentum. Momentum before an event. Momentum before an event is momentum after the event. Momentum before an event, that is same as momentum after the event. For example, if I consider one object and I will consider the mass, so object A, and another object, that is object B. These are the two objects I consider for deriving the expression. So object A and object B. So now for the requirement for the momentum is one we require mass and another is velocity. So first thing, I will draw a little. So I will consider this as object A and this as object B, and mass of object A is m in A. So A has the subscript. Okay, I wrote A as a subscript for m. So m A means mass of the object. Object is A here. Then if you consider B, mb is mass of the object. So now initially they are moving in a particular direction, or if they are moving in the opposite direction. Then UA, small letter u and subscript A, and UB, UA and UB. So here A and B are the two objects. MA and MB are the mass of object A and B, and UA and UB are the initial velocity of the object A and B. Now while it is moving, suddenly it collides with each other. Okay, in this case they are colliding with each other. That means they are intersecting with each other. A. This is B. Mass of the object MA and mass of object B is MB. Initial velocity is UA and initial velocity UB. Now this is force F1, and from this side it is F. So this is before collision. So this is at a moment of collision. Collision means dashing of the two objects. Okay, this is before collision. Then this is after collision. In this place, I will again consider object A and object B. So mass remains same, ma and mb are the masses of these two objects, and the velocity becomes, after collision it becomes va and vb. So ma and mb are the mass of object before collision, at the time of collision, and after the collision. UA and UB are the initial velocity of the mass, initial velocity of the object A and object B. And after collision, VA and VB are the final velocity of the object. Okay. So now we have to find out what is the expression for conservation of momentum. So according to conservation of momentum, so momentum before an event, that is same as momentum after the event. So momentum is a product of mass and velocity. It is product of mass and velocity. So therefore, the momentum before collision, momentum before collision, that is equals to ma UA plus mb UA. Okay, ma UA plus mb UA. Because you have momentum of the first object. So now this is before collision. Okay, this is before collision, and this is after. So first phase is before collision, this is after collision, this is at the time of collision. So collision means the dashing of the two objects, or when there is an interaction, not interaction, the dash. Okay. Now we have momentum before collision. So as I told you that momentum is product of mass and velocity. So here two objects are present, object A and object B. So therefore, momentum of object A is ma UV, because it is product of mass and velocity. Mass is ma and velocity is uv. So therefore, ma uv. And for the second object, the mass is mv and velocity is uv. So therefore, the momentum is mv uv. So therefore, ma uv is the momentum of object A, and b ub is the momentum of object B before collision. So therefore, I will add these two expressions. Therefore, I will add and write ma uv plus mb uv. Now we have to find out the momentum after the collision. Momentum after collision. Again, we have two objects, same two objects, and mass of object is ma and mass of object is v. So therefore, the momentum is its product of mass and velocity. So therefore, it becomes MAV plus the mass of object B is mv and velocity of object B is vb. So therefore, momentum is product of mass and velocity. So that's why it becomes mv v. mv. Just look at that expression. The momentum before collision and momentum after the collision. This is about momentum. And according to law of conservation of momentum, the momentum before collision is same as momentum after. Just write the statement of conservation of momentum. After this, just write. So note on the point. According to law of conservation of momentum, just note down. According to law of conservation of momentum, momentum before an event that is same as momentum after the event. So after these two statements, we are right. According to law of conservation of momentum, momentum before an event that is same as momentum after the event. Therefore, it becomes MAUA plus MBUB, that is equals to MAVA plus MBV. Okay, MAUA plus MBUB, that is equals to MAVA plus MBVB. So this is the expression for conservation of momentum. So once again, I will repeat the statement of conservation of momentum. The momentum before an event, according to law of conservation of momentum, the momentum before an event that is same as momentum after the event. Okay, that is a very, very important statement. Okay, so how many of you understood this? Just comment your name. Fast, comment your names. Now I'll repeat all the Newton's three laws statements once again. Listen carefully. According to Newton's first law of motion, every object continues to be in the state of rest or of uniform motion unless an external force applied on it to change its state. And according to Newton's second law of motion, acceleration given to a body is directly proportional to applied force and in the direction of the force, and it is inversely proportional to mass of the object. And according to Newton's third law of motion, for every action there is equal and opposite reaction. Thank you everyone. I'll continue in the next class.